so let's talk about the behavior of graphs of inequalities. So I would start or shift up. This is a graph. Let's talk about behavior of graph on this. It's shifted up, shifted down one, right? And then it's going to be kind of steep, or up to over 1, up to over 1. It's going to be a solid line instead of dotted. And it shades upward. Good. Uh-oh. It's because it's on the square. All right, so this one is going to look like shifted up. It's going to be in the negative direction, and it's going to be not as steep, right? Because it's 1/3, same behavior, correct? So up 1 over 3, and it's going to be a dashed line. I can dash my line like this. It's up 1. You can go down and this way. I always go up and then either to the left or to the right. It gives you the same thing, right? Okay. And I'm going to shift up or down? Or shade, I should say. I'm going to shade up. And if you didn't know which one to shade, what could you do? Test a point. And the easiest point to test? 0, 0. Good. All right, so graphing and solving quadratic inequalities. Pencils down. So there are lots of different ways that you can solve this. Evan? It says pencils down, right? So don't worry about it right now. Okay. So see how you just broke our concentration? Okay, so Evan, that needs to be a personal goal, right? To not do that as much. Okay, so I could factor this. I could use the quadratic equation, or I'm sorry, the quadratic formula. Or I could, I'm going to complete the square because I just think completing the square is just wonderful. It shows you everything really quickly, and I'll show you how. So I have x squared plus 2x, half of 2 is 1. 1 squared is 1, right? And if I add 1 to both sides, if I add 1, I also have to subtract 1. So I have x plus 1 squared plus 3. So my vertex is -1, positive 3. I also know that 4 is my y-intercept, so don't I have a graph now? See how quick that was? So it's going to be a solid line. So I have a solid line here. Now I just have to, it's not just this line with an inequality, right? An inequality is talking about the space. So which space are we going to shade? The outside or the inside? How could we tell? I'm going to test a point. I'm going to test 0, 0 and see what I get. With, just hold on. With the original equation, I'm going to test 0, 0. So 0 needs to be less than or equal to 0 plus 0 plus 4. Is 0 less than or equal to 4? Yes. So my solution space is everything on the outside of this parabola. Now, do I have questions? Do you have questions? Yes.
I see how you got the vertex. How'd you get the other two?
Because my y-intercept is at 4.
Oh, so it's symmetrical.
And it's symmetrical. And because it didn't ask me for an axis of symmetry, and it didn't ask me for a vertex, technically, right, all it tells me is graph. So all it really wants is a rough sketch of what that looks like. You don't have to provide all of that unless I ask for it. Yes?
So on the homework, one question that we didn't have that top part, but just when it's already complete. How do we find the other two questions? They don't give me the answer.
Can we ask that when we get to homework questions? Just don't forget, okay? I want to keep with the flow of what we're doing. Okay, so you guys try this one. Actually, I'm going to have you copy this down first, and then I'm going to have you try the next one. Okay, so the first thing we want to do with this one is pull out a negative. because it's much easier to factor if I pull out that negative. So I would have positive 2x squared minus 3x minus 5. I'm going to remember that this graph should be frowning, right? Awesome? Because I pulled out a negative from everybody. And if you factor out a negative, you get 2x squared. Look, if I were to just distribute it, got it? Okay, so now I'm looking at it saying, you know, completing the square, it doesn't really work with this one, right? I'm going to try factoring it. It's not going to be very easy to factor it either, so let's use an X box. Okay, Josiah, calm down. So I have 2x squared and negative 5. What goes up here? This is my attic. Negative 10x squared. And what goes in my basement? Negative 3x. So what two numbers when I multiply I get negative 10, but when I add I get negative 3? Negative 5 and 2x. So I have negative 5x and 2x. If I factor, what can I factor out of here? 2x. 2x times what makes 2x squared? X. And 2x times what makes 2x? 1. And this is negative 5. So I put 2x minus 5 here and x plus 1. So that was a nice little factoring activity, right? To help you out for the test. So let's solve that. What are my two roots if I solve this? 5 halves, x equals 5 halves, or x equals negative 1. So I'm going to go ahead and graph that. Here's negative 1. 5 halves is 2.5. I also knew my y-intercept, don't I? 5. So I could actually graph this. I need it to be a dashed line pointing down. I don't need a vertex. Did they ask for a vertex? No. Nope. 2.5. Because 5 halves is 2.5. Okay, so now we got to figure out whether it's everything shaded inside or everything shaded on the outside. How do I know? Okay, so there's a lot of rules on how you can figure out whether it's greater than or less than. Lots of things talking about the graph pointing down, pointing up, A being greater than 1, less than 1. You know how much I love rules, right? So if you want to know the rules, go in the book and study them. I'm going to talk about common sense. What could I test to figure out whether it's inside of the graph or outside of the graph? 0, 0. So 0 is less than. If I substitute in 0 for that x, I get negative 2 times 0 squared plus 3 times 0 plus 5. Is 0 less than 5? So is 0, 0 part of my graph? Yes, I'm sorry, part of my solution. Yes, it is. So I'm going to shade it. Shade inside of it. Those are all solutions to this graph. Yes. Not really. It is, but it isn't. We already know how to do this with linear inequalities, right? Now we're doing it with quadratic inequalities. It is, I mean, that's what I really like about this lesson is it's kind of pulling everything together, right? So we're reviewing little pieces everywhere. Are you trying to get me upset?
PhD in mathematics.
Okay. Pencils down. Now, the difference between this example and the last example is huge. The last example asked me to graph it. When I graph it, I have to include the shaded plots, right? Because that is what it means. An inequality means all of the area within a certain space. It didn't ask me to solve it, it asked me to graph it. Graphing includes all that shaded region. This is asking me to solve. When we solve stuff on a graph, what does that normally include? Not just x, but the roots, right? You usually have, just like on this one, if I were to solve it, you'd tell me that, -1 is a root and 2.5 is a root, correct?
Right.
Well, isn't there also roots all right here? Aren't those all roots?
But it's not part of the solution.
It is, but is that a root up here? Is that a root down here? Those are just the solution space. What the solution space means is that if I were to substitute in 0, 1, would that satisfy that inequality? Yes. If I were to put in -10, 0, would that satisfy it? Yes. Any one of the points in here, if I were to substitute it in here, it would satisfy this inequality. I would get a true statement. But if I want to know the solutions, the roots, isn't there, this is going to be a little bit abstract, but isn't there an infinite number of quadratics in here? Right? If you really think about it, isn't there an infinite amount of them in there? Correct? So isn't there a whole bunch of solutions on that line right there? Make a little bit of sense? Okay, that being said, that's what we're going to find right now. We're going to find the solution to this graph. So how would you solve this one? I told you that I like to do completing the square. Is that a good one to do completing the square? This is why, right here. My vertex is going to be way down here. So I think this one would be better to factor. So x and x, 7 and 5. Just let me do it first. Which one's going to be positive? Which one's going to be negative? -7, +5. So my roots are 7 and -5. So here's 7 and here's -5. And that kind of makes sense because look how wide it is. That means the vertex is way down here. Can I graph -35 as my y-intercept? No, it's way down there. So this is less or equal to, so it's going to be a graph that looks something like, I don't know, that's a really bad representation, but that's kind of what it's going to look like, right? I'm not really concerned about this part. What I'm concerned about is from here to here, from here to here, and from here to here. Because I'm talking about my solution. It's asking me to solve it. So what do you think I'm going to do? 0, 0. Remember when you were so against my whole 0, 0 thing? 0 is less than or equal to 0 squared minus 2 times 0 minus 35. 0 is less than, is 0 less than -35?
No.
No, that's a false statement. So is 0, 0 part of my solution? Nope. So it must be everything this way and everything this way. Let's try -6. So 0 is less than or equal to -6 squared minus 2 times -6 minus 35, which is 36 plus 12 minus 35. What's the answer? Is 0 less than 13? And I'm guessing if you put in -8 and -9 and -10 and -11, all of those would be part of the solution, right? So let's go the other way. Let's put in, I don't know, 10. I don't want to work with 11. I'd rather work with 10. So So 0 is less than or equal to 10 squared minus 2 times 10, which is 20, minus 35. 100 minus 20 is 80. What's 80 minus 35? Doesn't matter.
Somewhere in the 40s.
45. So is it true?
Yeah.
It is. So my solution space, sorry, not space, but my solution on the graph. Now here's the only difference, right? Now I can't just put my space right there because it's not really all that space. That's not my solution, right? My solution is all the numbers, and we're talking about x. X is less than or equal to what? Or greater than or equal to 7. That is my solution to this graph. You try 9.25. You tell me how that works out. I'm pretty confident that it will be a solution. Questions on this? Okay, you can try this one. All right, so let's try this one. How'd you guys work this one out? Anybody do complete the square?
No, I did that. I did.
No? Okay, I'm going to complete the square. X squared. No, I don't want to complete the square. Why would I do that? Because it's odd, right? So I'm going to factor it. X and X, 2 and 1, both of them have to be negative. So X equals 2 and X equals positive 1. 2 and 1. Now normally I would think this is really, really super skinny. But it's not super skinny because, look at, 2 is my y-intercept. So doesn't that mean that that's right there? So check this out. So it's probably, the vertex is probably somewhere like right there. See what I did there? Don't, the axis symmetry is right in between them. But we don't, it didn't ask us to find it. But wouldn't it be right there in the middle?
Mm-hmm.
All right, so what am I going to test?
0, 0.
Test 0, 0. So 0 squared minus 3 times 0 plus 2 should be greater than or equal to 0. Is 2 greater than or equal to 0? Yes.
So it's true.
So it's true. Therefore, my solution space would be there. And most likely, here, right? Unless, here's an unless, and this could be true. No, it couldn't. I was going to say,
You have to use that low resin.
yes.
Yeah.
You're just, this is, it's a solution to this. It's not all this space, right?
Yeah.
It's all of the parabolas in this space, right? So it's every time it's crossing an X.
Do you graph the number line?
I would
I mean, just shade the number line.
just shade the number line because my solution is X such that X is less than or equal to what? No.
1.
1. Or X is greater than or equal to 2. All the numbers from here to in that direction and all the numbers from here in that direction. Right, Ryan? Questions on that? All right, so I think the next one's pretty easy. So it says to solve algebraically, so we're also finding zeros again, right? But it's lying because I see a line here, and isn't using a line really graphing something, right? But it does say algebraically. So I'm going to add 6 to both sides so that I can find my zeros. Might as well just, I don't want to complete the square on this one because that's a 5. And besides that, I'm not looking for a vertex. Completing the square would give me vertex form. So X and 2 and 3 So my zeros are -2 and -3. This is -3. This is -2. I'm putting them really far apart because I'm going to do 3 different solutions here. So what point would I test this direction of my line? -4. So let's substitute in -4 squared plus 5 times -4 should be less than -6. I get 16 plus 20, sorry, minus 20. So is -4 less than -6? Nope, so that's not part of the solution. Now this isn't going to be very fun. Let's do this one last. Let's do over here. What could I plug in over here? 0. So 0 squared plus 5 times 0 is less than -6. Is 0 less than -6?
Nope.
No, that doesn't work either. The only one I actually have to do, and I kind of need to check it just in case it's all real numbers, right?
Yeah.
Which really wouldn't make sense. But let's do it just because we don't want to be lazy. 2.5, that would work. -2.5. So it's okay, you have calculators, right? -2.5 squared plus 5 times, please stop, is less than -6. 2.5 squared is 6.25. 5 times, well, 25 squared is 625, add 2 decimals. Plus, sorry, minus 12.5
Yeah.
is less than -6. -6.25 is less than -6. Is that true?
Yeah.
It is, so there's my solution space right there.
So it's just that.
It's just that. And if you think about it, isn't this really a parabola?
Well,
If you put it that way, right? It's really a parabola that I'm drawing there. So, you prefer the parabola?
No, I prefer this.
Okay, then you do this.
I like this one better.
I personally like to see it. I like the whole picture. Okay, so x is in between what 2 values? -2 and -3. X, such that x is in between -3 and -2. That's your answer. Question. I'm so moving you guys on Monday. You guys talk too much. No, well, everybody, it's been 2 weeks, right? So I shouldn't really be recording this conversation, right? Oh, they got quiet all of a sudden, huh? Okay, does anybody have any questions on this? Ready to do the last one? All right, you guys do this one. Okay, so how'd you guys factor this one? X and 6 and 5, both of them are positive. So I have, guys, I'm recording. Can you guys quiet down, please? All right, so here's -6, and here's -5. I'm going to test what? Test 0, 0 first. If I test 0, 0, what do I get? Does it work? Is 30 less than or equal to 0? So I'm guessing if I test that, that's also not going to work.
-5.5.
I'm not going to. There's my solution.
Wow.
That's not great. X is less than or equal to -5 and -6, X such that. Good. Good. Okay, what did you learn today? Graphing quadratic inequalities.
Learning what a graph is about, right?
All right, I need a quiet, please. Quiet down. The difference between solving and graphing an inequality is what? Wow, I spelled a whole bunch of stuff wrong on here. What's the difference between solving and graphing an inequality?
You don't need that. Why?
fading.
The bottom point of it, right?
You don't need a line of it.
No. You guys are missing what I'm asking. There's a difference between graphing an inequality and solving an inequality.
And then solving is just
Graphing is, oops, I did it again. Graphing is the actual shading, right? Solving is the zeros in the shading. That's today's. Copy it from somebody else.
Aw, I'm still on the wrong page.
Okay. Good job, guys.
Okay.